I was at a thrift store digging through the toy section when I found this. A tiny beat-up $1 xylophone. It looked completely useless, which meant it was perfect. Not long ago, I built a robot that plays actual wine bottles with solenoids, just to see if I could. Then I built a synthesizer powered by fidget spinners. Yeah, really. And at some point I realized I wasn't just making weird instruments, I was chasing something bigger. A completely absurd, fully robotic orchestra. Built from scratch, from junk, from joy. So this little xylophone became my next musician. Now it lives in a suitcase. Plays a welcome tune when you open it, has buttons for every note, and listens to MIDI input from a computer. And of course I couldn't resist teaching it 6 meme songs, because why not? Also, I might have fried an Arduino. Okay, let's dive in. My first step is making a 3D model of the xylophone. From the very start I knew it had to live in a suitcase. And then at a flea market I found the perfect one. 10 euros. Like it was waiting for this project. I added the suitcase to my 3D model and watched how my hands would naturally rest on a surface. Every xylophone note gets its own button. Ergonomic. To play the notes I'm using solenoids. When we send a current through them, the blue part becomes an electromagnet that pulls a metal pin inward. A spring pushes it back out. With an optocoupler and a microcontroller, I can control that precisely. This is also what powers the flippers and auto lunge in pinball. I added the solenoids to the 3D model, plus mounting holes for the control electronics. In the center I added support holes for a pillar to prevent sagging, though later I found a better solution. Since the inlay was too big for my printer, I split it in two. I tested the component fit and the snap fit connection with 2 quick prototypes. With those done, I printed the final inlay and clicked everything together for real. Started mounting the components and then disaster.
Oh no!
Screws right through the front. But don't worry, as I confidently declare in the heat of the moment.
We will place this xylophone here anyway, so you barely will see it.
Next, I glued the 3D printed note labels in place and wired everything up. These spring clips can really snap hard if they catch your fingers.
Ow! Fuck die cut clips.
You know what? I wouldn't need those if I just made a proper PCB. And right now is the perfect time. PCBWay is celebrating their 11th anniversary with exclusive coupons for 30 days. Upload your files, customize your board, and they'll take care of the rest. Check out the link below and happy anniversary, PCBWay.
So this plug is converting 5 volts into 12 volts. And I think the circuit is drawing too much current. So we'll have to try with a decent power supply. And only the best is good enough for me. This €1.50 second-hand laptop power supply. Okay. Should be more stable.
The notes finally started playing, but they were reversed from high to low instead of low to high. I fixed it by reversing the inputs in the Arduino code. To teach the robot songs, we need to do 4 steps, and the 5th step is the robot actually playing the song. The first step is playing the song on this tiny MIDI keyboard. It's basically a piano that doesn't make sound, but sends digital notes to the computer. I recorded those notes in Ableton Live and exported them as a .mid file, a kind of musical recipe. It says which notes to play and when. I converted that file using a tool called MIDI tones, which turns it into a list of instructions the Arduino can follow. But when I tried playing back the Tetris theme, something felt off. Some pauses were way too short. Let's take a quick look at how this list of note instructions works on the Arduino. First, we see 0x90. That means start playing a note. The next number is 81, which is the pitch. In this case, a high A. Then we get a 0, which means wait. The number after that is 125, so we wait 125 milliseconds. Next is 0x80, meaning stop the note. And here's where I got confused. I saw a 1 followed by 119 and thought, oh, another wait command. But actually, that 1 and 119 together form a single 15-bit delay value. If the first byte starts with a 0, it's not just a command, it's part of a 2-byte delay instruction. That's why short delays worked fine. They only needed 1 byte. But long ones came out too short. After all this, we're ready for the next note with another 0x90 start instruction. Ha ha ha, now it works! I wanted the little switch to play a welcome tune when you open the case, so I had to carve out some space. Clueless about which bit to use, I just grabbed something that seemed right. I'm definitely wearing the safety glasses after what happened last time. So at this point, everything looks okay. But at this point, I realized I had fucked up.
Jesus. Holy fuck.
So yeah, safety glasses. Sadly, all I did was burn the wood. So I grabbed the jigsaw, which I grabbed in the dumbest way possible. Luckily, I noticed just in time and switched.
That's stupid.
I added the pass-through for the power cable and figured, why not power the Arduino from that too? It should handle 12 volts on the raw input. Spoiler alert, it did not. Everything started glitching and then smoke.
Oh. Oh! No! It is really hot.
You know what? We'll just use USB for the power supply. We need it for MIDI anyway.
And now the moment of satisfaction. Will this all fit? That's cool. Can we close the lid? Yes. Can we flip it around? Yes. Is everything still in place? Yes. Oh.
Some of the notes don't play. Felt underneath, not exactly precision engineered. But hey, that's what you get when you repurpose cheap discarded kids' toys. Luckily, software to the rescue. I just made the solenoid pulse a bit longer. Problem solved.
Fuck me. Maybe this will help, because it's hurting my ears. I actually like it better with the duct tape on. Okay, after just 5 minutes of coding, I added this. Isn't that amazing? Ha!
Can you guess all 6 songs? Put your answer down in the comments. And that's it, the MIDI Xylophone lives. If you liked this project, check out my fidget spinner synth or the wine bottle playing robot I built earlier. They're both wild, they're both musical, and they're right here on the screen. Thanks for watching and see you in the next one.